So this is going to be a video lesson for section 2.5. This is going to be the last section that we will cover in chapter 2, because we already covered 2.6 and we're skipping 2.7. This is the last section that we will cover this trimester, so it's the last section for a lot of things. 2.5 has two components. It's titled Dividing Rational Numbers, and 2.4 before it was Multiplying Rational Numbers. So it's in some ways similar, and it has two components: multiplying fractions and then multiplying decimal numbers. So I'm going to tackle multiplying fractions first, because that's the easier part here. The first thing you need to know is what is a multiplicative inverse or a reciprocal. If I have two numbers like this, or just a number like this, a fraction, let's say 1 over 2. The multiplicative inverse, or the reciprocal, is any number that when multiplied by this will make the product be 1. So what can I multiply half by to make it a 1? I can multiply it by 2 over 1. And in this case, when I multiply it by 2 over 1, I get a cancellation, or the simplification of the 2's, which yields just the 1. If I have 3 over 4, what can I multiply the 3 over 4 to make it into a 1? I can multiply 3 over 4 by 4 over 3. It's multiplicative inverse. In this case, I can cancel out the 4, 4, 3, 3, which gives me a 1. 11 over 12. You guessed it, 12 over 11. So the multiplicative inverse is essentially, you take that fraction, you flip it, and you get its reciprocal, or the multiplicative inverse. So why is that important? Let's say I have two numbers like, or this expression here, 5 over 6 divided by, let's go with 2 over 3. Now, dividing fractions is kind of tough, not the easiest thing to do. So we don't have very good rules for dividing rational numbers, but we do have rules for multiplying them. So the easiest thing to do is to convert the convert the division into a multiplication. How do we do that? Well, first we change the operation from division to multiplication, and then we multiply by the reciprocal, or we take our second number, the divisor. This is the dividend, this is the divisor. We take the divisor and we flip it, and in turn we get 3 over 2. So 3 over 2 is the reciprocal, or the multiplicative inverse of 2 over 3. So to change this division to multiplication, you take your divisor. The second number always has to be the divisor, never the dividend, never the first number, and flip it, or multiply it by its reciprocal, whichever root makes more sense to you. And when you do this, now it's multiplication. We have very defined rules for multiplication. You multiply across. But first, I always suggest you try to simplify. So I have a 5, I have a 3. The 6, I can write that as 3 times 2. And then I have a 2. And then I see if I can cross anything out. Not much, but I can get rid of these 3's, which does make my life a little bit easier, because now I don't have to multiply anything at the top, and at the bottom I have 2 times 2, which is 4. So that was not so bad. Once you convert the division into multiplication, this is just like the problems that we worked at in section 2.4. Let me give you another example. Let's say we have 2 and 1 over 3, and it's being divided by 1, and let's go with 4/5. I'm making these up, so I don't know what the outcome will be. But the first step is to convert both of these into non-mixed numbers, or improper fractions. 2 times 3 is 6, plus 1, that's 7 over 3, divided by 1 times 5 is 5, 5 plus 4 is 9 over 5. And I feel like I won't be able to cancel anything out here, but oh well. So once again, we don't have any rules for division. So what we can do is we can change it to multiplication by multiplying by its reciprocal or flipping the second number, the divisor, on its head. Then of course you want to check to see if there's anything you can do to simplify. And there isn't, unfortunately. 3, no. 5, no. 9, no. 7, no. And I can break this 9 down to 3 times 3, but it's not going to help me. Unfortunate, I know. So you multiply across. 7 times 5 is 35. 3 times 9 is 27. You can leave it as an improper fraction, or you can convert it down. I'm okay with either way. Then let's do just one more quick example. Let's go with, you know what, I think that's good enough. You do get the gist of this, when you divide two fractions, change the division to multiplication by flipping the second number or multiplying it by its reciprocal, and then do what you did in section 2.4, and I have quite a few videos with problems worked out for 2.4. The second part is a bit more interesting, so I'm going to concentrate a little bit on that. Let's say you have a pair of decimals that you are trying to divide. So you have 0.384 divided by 0.24. Just like with fractions, dividing decimals, not the happiest place to be when you do that. So you want to avoid that as much as possible. Now, unlike fractions, you don't want to convert this to multiplication and flip it to its reciprocal, because these are not fractions. The reciprocal of 0.24 is 1 over 0.24. Doesn't really make anything any better. So instead, this is what you do. You convert both numbers into whole numbers. How do we do that? I am literally going to take my decimal here at the number that has more numbers after decimal, and I'm going to move it over as many times as I need to make this into a whole number. 1, 2, 3. I moved it 3 times. Now it's 384. Magic. Here, I'm going to do the same thing. To keep the division equal, I need to do whatever I do to the dividend, I need to do the same thing to the divisor. So I'm going to move the decimal here once, twice, the third time. So what I end up with is 384 divided by 240, because there was a 0 that you would fill in here. And this is fair game. Why is this fair? Take a look at this. 4 divided by 2 is 2. 40 divided by 20, still 2. 400 divided by, or 4,000 divided by 2,000, I guess I skipped a multiplicative of 10, but that's still 2. 40,000 divided by 20,000, that's still 2. So I can change the division problem by, I can multiply it by anything I want, as long as I do it to both the divisor and the dividend. So as long as I keep the fraction intact in terms of its balance, it doesn't matter what you raise the number to, as long as you're raising both the denominator and the numerator to the same value. So here I can make them whole numbers. I literally multiply the 0.384 by 1,000. That's what it means to move the decimal over 3 times. And I multiply the 0.24 by 1,000 as well to keep everything fair. And now I have whole numbers. Yay! Whole numbers are easy to work with, because now I have a long division problem that's fairly easy to complete. 240 goes into 384 once. I get 144. 240 does not go into 144 decimal, and that's 6. Done. That wasn't bad at all, I don't think. I'm going to have to do a part 2 to this, where I'll work out a few more problems like this. So I'll be right back.